Welcome back to W.D.Y.D CSP. What do you do as a central sterile processor? Today we are cleaning the DaVinci SP camera. Also pictured here is the DaVinci XI camera that I'll be cleaning in a separate video. Alright, both cameras are very similar, but very different as well. One requires ultrasonic cleaning and the other one does not. We are utilizing a 3-bay sink setup here for the cleaning process. And the first sink is dedicated to rinsing, and the second sink is dedicated to the soaking washing. The importance of rinsing prior to soaking and cleaning is to remove any pre-treatment sprays, foams, or gels, as well as remove any visible soil that we may see that can be easily removed simply by rinsing. Okay, we use a spray hose and or free running water to go ahead and rinse this device. You want to follow the IFU as closely as possible. Now the IFU does start during the soaking process. Again, this is because the teachings of the tech manuals and of the standards designates the first bay as the soaking bay, but we do not want to violate OSHA policies or regulations in that OSHA states we should not mix chemicals. The pre-treatment gels, foams, and sprays are typically different from the soaking chemicals that we use in decontamination. So it's important that we remove those first. Now, per the IFU, we want to flush the flush ports. The DaVinci SP has 2 flush ports on the face of the control box there. Okay, I am using a spray jet gun to go ahead and flush both of those ports. Again, follow the IFU for the length of time that is required or the quantity of water that is required to flush those ports. Okay. We then want to go ahead and switch over to the soaking / manual cleaning sink. Okay, this sink is filled up with a predetermined level of water with a measured amount of detergent. Okay, temperature is extremely important when utilizing certain detergents. So again, follow your IFU. Okay, as you can see, I am placing the hose in there in a neat fashion, and I'm being careful not to hit the distal tip of my device onto the metal surfaces, because there is a glass eye on there that I do not want to damage. When you're soaking in a device that has cannulas and lumens, you want to do what's called priming. Priming is filling those cannulas and hollow spaces with detergent to remove the trapped air and allow for the detergent to not only clean the external surface of the device, but the internal surfaces of this device, which we cannot visibly see. All right, so you may have to prime a few times in order to remove all and any trapped air. Now, as stated earlier, this device soaks for 15 minutes. Okay, for video purposes, we're going to fast forward and skip that 15-minute process so that I can show you the next step in the process. But this is the challenge that we face with these robotic arms and robotic devices, in that the soak time is a prolonged time. Okay, now after the soaking time, you want to go ahead and manually clean the surfaces of this device. And you want to utilize a host of tools, whether it be a low linting towel, a sponge, or a nylon bristle brush to get the areas of the device that can articulate and or move around. Okay, you want to use a sponge or towel to get the large surface areas of the device. Mainly the shaft, the insert shaft, the control box, the cable, and the connector. All should be wiped down with a sponge or a low linting towel. Okay, again, paying close attention to the distal tip and not damaging it or hitting it against metal items too hard. Okay, there are some articulating joints at the very end that you want to get some good detergent soaked in there. Okay, you see me changing the configuration of where the hose is at, or the cord, so that I can get to the cord and properly wipe that down with this sponge. Okay, and you just want to grab the sponge and ride it along the entire length of the cord. Okay, applying sufficient friction while keeping the device under the surface of the water to prevent as much aerosolization as possible. Okay, it's important to untangle your cord. Okay, once I get to the end, I want to concentrate a little bit on that connecting block or unit. You want to check the very end where it connects, as well as the ports inside of the connector. So you see me looking inside of that port to make sure that it's nice and clean. You're then going to carefully transfer your device over to the final bay, which is the rinsing with treated water. Okay, but before we do that, we want to go ahead and use a brush, and we're going to use the bristle side to clean the articulating portion of this device. There's like a little honeycomb area on this device that articulates in different ways. We want to concentrate with the brush to get into those areas, those hard to reach areas. Okay, being careful never to use the metal side of this brush, always the nylon side of the brush. Okay, because there's some little wires in there that we do not want to fray. Okay, once we do that, we want to use a spray force to rinse or spray those articulating areas. So I'm using the spray gun under the surface of the water, okay, to get to those areas there. That will dislodge any soil or any detergent that's trapped in those little areas there. Okay, and then we want to go ahead and we want to flush those ports that we primed earlier. Okay, again, this is to remove any soil that may have been loosened and expel some of those detergents. Now, yes, this is water that I'm using in the detergent bay, and I am diluting the concentration of my water, but this water is going to go ahead and get emptied and refilled. So we want to use as much caution when we're rinsing and flushing ports out. If you have a gun that dispenses pre-mixed detergent, that is probably your best practice. The other option is to use a syringe to do the flushing as well. All right, the last step is the critical water rinse. Okay, again, follow the IFUs to see how much critical water is required for that final rinse. Okay, it's going to give you a time or a volume. What's important is that you get all the surfaces of this device to remove any microorganisms and or any residual detergent that may be latched onto the instruments. Okay, good copious amount. Follow the IFUs again to determine how much water or time is required for rinsing. Okay, you also want to pay attention to the ports as well, because again, there's still detergent trapped in that port, in those flush ports. So you want to go ahead and grab a syringe. You want to go ahead and get if you don't have one, a small bowl, basin, or cylinder, and fill that up with treated water. You want to draw up some treated water and you want to flush those ports to remove any detergent and or microorganisms / soils that may have gotten loose during the cleaning process. All right, so I'm rinsing this cylinder out here, okay, or this beaker, whatever you want to call it. Okay, fill it up with some critical water, grab my syringe, draw up some critical water and flush those ports out. Okay, and it's a nice aggressive flush there. This is a 20 cc syringe. You can go ahead and use a larger one. So 40 cc's of volume that was used there to flush the ports, okay? 20 per each port. All right, and this is how we rinse, manually clean. Now we're gonna place the item in the ultrasonic according to the IFU. You should use an irrigating sonic. If you don't have an irrigating sonic, then again, you must prime your device with detergent prior to placing into the ultrasonic. Okay, it requires a set amount of time of ultrasonic cleaning. Okay, so you want to go ahead and place your ultrasonic on the appropriate cycle. Connect your device. Only one scope can be placed in the ultrasonic at a time according to the IFU. You want to go ahead and start your cycle, and then there is an additional step after cleaning that's required for this device, and that step is a leak test. Okay, the leak test determines if this device was damaged during the cleaning process. Now, I believe that this step should be done prior to cleaning, but the IFU specifically calls this step out after the cleaning process. Okay, the test goes as follows. You want to use a leak tester, and you're only going to submerge the distal tip of the device that has the wire mesh or honeycomb pattern in it. Okay, this is the leak tester that we're utilizing for this device. It inflates the device with a PSI pressure, or not a PSI pressure, a pressure of millimeters per mercury of 140 to 181. And you want to go ahead and fill up your sink with just water, no detergent. You want to go ahead and connect your leak tester to the leak testing port that's located on the top portion of the control box. Submerge the distal tip and agitate it a little bit to release or remove any bubbles that may have formed on the surface of the device. You then want to turn your leak tester on, and you're going to test the device for about 30 seconds. I'm trying to move this cord out the way, and I apologize because I'm trying to do this with one hand while holding the camera with the other. All right, so we're going to turn this unit on, and we're going to observe the distal tip for about 30 seconds. Okay, make sure that it's connected properly. Check the distal tip, and the unit should be running. So you got 150 millimeters of mercury. It should be between 140 and 181 and should hold steady. Okay, so this is holding nice and steady at 151, 152. I see no physical bubbles coming out of this unit. And again, how you determine 30 seconds? You either place a timer on, or you sing happy birthday 3 times. All right, guys. Peace.